Learn, grow, succeed with Tiwari's Academy.
Jai Shri Krishna, Radhe Radhe. My name is Akhilesh Tiwari and welcome to recorded videos of Tiwari's Academy. Today we are going to talk about second part of Trigo. In the first video we saw what is trigonometry, basic, very Shokatova. But in today's class, beta, all the kids, this is for all the kids basically. In today's class we are going to talk about further part of trigonometry. Now what is this further part of trigonometry? Now further part of trigonometry means basic, the second part of trigo, that is what is complementary angle. Then after that we'll see what is identities of trigonometry, and the third part is going to be heights and distance of trigonometry part. Now heights and distance comes under application of trigonometry. Okay, so now in the first video we have already seen what is my Shokatova, how do we calculate sine theta, how do we calculate cos theta, and how do we calculate tan theta. In today's class I will talk about what is complementary angle. I think I gave a basic idea of what is complementary angle, but still I'll again repeat the things which we have done already in the first recorded video of introductory to trigonometry. Okay, so now first I will draw a triangle. Now please remember, trigonometrical ratios can only be used in right angle triangle. We cannot use in any other triangle. There are some other rules and there are some other trigonometrical rules which we can use it in isosceles, scalene, other triangles, but not in right angle triangle. So now I will name it as A, B and C. Alright. Now I am going to assume let angle C be theta. According to Shokatova, Osha Chota, whichever you are convenient with, you can use that. Both of them are very much used in finding the ratios. So Osha Chota. Okay. Now sine stands for, sine theta will stand for O upon H, cos theta will stand for A upon H, and tan theta will stand for O upon A. This was our basic Shokatova which we saw in the previous class. Now today we are going to talk about what is my complementary angle. Now complementary angle, you must be having some basic idea of complementary angle. Now complementary angle is something where the sum of the angles should make up 90 degree. So now beta, when we talk about sum of the angles should make up 90 degree, that means if I talk about right angle triangle, in right angle triangle one of the angle is 90. If I am assuming one of the angle to be theta, then what about the other angle? Other angle will be 90 minus theta. Why? The reason is because sum of all the angle of a triangle is equals to 180. Okay, so now complementary angle means if sine theta is something, what will be sine 90 minus theta? If my cos 90 minus theta will be something, what will be cos theta? Will there be any relation between my sine theta and sine 90 minus theta? Will there be any kind of relation with my cos theta and cos 90 minus theta? Will there be any relation between tan theta and tan 90 minus theta? So this all relation which we are going to see today, now that comes under complementary angles. Okay, so now first we will talk about, I'll just give you a basic idea. Now since I'm talking about my sine theta, if I assume this side, now this side is opposite to theta, this side is adjacent to theta, and this will remain hypo as it is. Okay. Now sine theta is what? AB upon AC. Cos theta is what? BC upon AC. And my tan theta is AB upon BC. Okay. Now let's see what will be my sine 90 minus theta, what will be my cos 90 minus theta, and what will be my tan 90 minus theta. Why I am giving you both the angles? So that at least we can have some kind of relation between theta and 90 minus theta, and then we are going to compare both of them in fact. So we'll compare both of them and we are going to see, is there any relation with my sine 90 minus theta with cos theta, or is there any relation with my cos 90 minus theta with sine theta? So this relation we are going to study in complementary angle. Alright. So now what is my sine 90 minus theta? Sine 90 minus theta is what? Now, according to 90 minus theta, according to angle A, my BC is the opposite side. So this will be now BC upon AC. Okay. Now, cos 90 minus theta. What will be my cos 90 minus theta? Now then, according to cos 90 minus theta, AB is the adjacent and hypo will remain same. So it is AB and AC. Okay. Now tan is what? Tan 90 minus theta. It is opposite upon adjacent. So it is BC upon AB. Alright. Now just tell me, students, if we compare both this column and we compare this column. Now sine 90 minus theta, sine theta was AB upon AC. Is there anywhere? Yes, we can also find AB upon AC. So sine theta is also equal to cos 90 minus theta, because they both are having same values, AB upon AC and AB upon AC. So from this beta, can we just correlate that my sine theta is equals to cos 90 minus theta? So I'll just write down the first part. So sine theta is cos 90 minus theta. Now second, BC upon AC. So I can see over here that my cos theta BC upon AC is same as sine 90 minus theta, which is BC upon AC. Yes. So now this time I will have cos theta is equals to sine 90 minus theta. Now what about now tan theta and tan 90 minus theta. So there is no relation with this, but again I will go back to some other parts. Now what are they? Cot. Can we go back to cot? What is my cot theta? What is my sec theta? And what is my cosec theta? Cot theta is again, it is just reciprocal of my tan theta, which is BC upon AB. Sec theta will be reciprocal of my cos theta, it will be AC upon BC, and cosec theta will be reciprocal of my sin theta, which is AC upon AB. Now we are going to see all the angles with respect to my 90 minus theta, and then we'll have a relation between all of them, and then we'll see which angle is corresponding to which angle. So which angle is complementary, in fact I should say which angle is complementing with the other angle. So this complementing wala angle we are going to find, and then finally this part will be clear. So now we got this. Now we'll see what is my cot 90 minus theta, what is my sec 90 minus theta, and what is my cosec 90 minus theta. Okay. Now what is my cot again? Now cot is going to be anyways is AB upon BC. AB upon BC. Sec is what? Reciprocal of my cos. So it will be AC upon AB, and cosec is reciprocal of sine. It is AC upon BC. Now chalo, we'll just match. Now we'll do match the column stuff. So we got it over here. So this was equal to this. Now tan theta was AB upon BC. Is there anywhere? Yes, there is. So here it is. Tan theta is equal to cot 90 minus theta. Now cot theta is what? BC upon AC. So BC upon AB. So now I will have over here. Now BC upon AB is equivalent to tan 90 minus theta. Now sec theta is AC upon BC. Can I have somewhere? Yes, sec theta is equivalent to cosec 90 minus theta here, and then finally this. So we are having all the relations So these are the complementary relations. Now I will go back to tan theta is equivalent to cot 90 minus theta. Now cot theta is equivalent to tan 90 minus theta. Sec theta is what? Sec theta is equals to cosec 90 minus theta, and cosec theta is sec 90 minus theta. Okay, so these are some of the complementary angles which we just did. Alright, now this was one part of the you can say second part of trigo. It was one part. Now we are going to see how to find the standard angles. Now since we spoke about theta angle, now we are going to see some of the standard angles. Now you must be knowing that my triangle can have many angles. Okay. Now when the triangles can have many angles, so now we'll stick to some of the standard angles. Now what are the standard angles? Standard angles are 30, 45, 60, 90. We have all the angles which come under from 0 to 360, but now these are some of the standard angles which we are going to learn in trigo. Now I will show you what are the standard values. What are the standard values with respect to standard angle of a right angle triangle. Okay. Now for that we are going to make a small standard angle table. Now that standard angle table is very simple to understand. In fact, now what will be sine 30? What is the standard value of sine 30? What is the standard value of sine 45? Standard value of sine 60, sine 90. Similarly, we'll go back to cos 30, cos 60, cos 90, cos 0 also, then tan 0, tan 30, tan 45 and tan 90. But again, you must be wondering, sir, how to remember all these values. It is not at all difficult. The reason why I'm saying it is not at all difficult to remember them is because we are going to make a magic square, you can say a magic square, a magic table, whatever you feel like you can say. Alright, chalo. Now we'll make a magic table. Now this magic table which I'm making over here, now in this I'm going to write angle on one side, and I'm going to write all the trigonometrical ratios on the other hand side. Alright, so now my first angle I'm going to use will be 0, then 30, then 45, then 60, and last is 90. Okay, fine. So my basic angles are, my standard angles are 0, 30, 45, 60, 90. Now my first, I will take sine theta, second cos theta, third tan theta. So right now I am just sticking to 3 of them, sine, cos, tan, because once you understand sine, cos, tan, automatically you will be able to find the remaining 3. Okay. So first sine 0. Now I will tell you the values right now. Just listen to them, and then I will show you how to make a table without memorizing the values of sine 30, 0, 45, 60, 90. So sine 0 is always 0. Okay, sine 0 is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2, and sine 90 is 1. Okay. Now these are the standard values of sine 0, sine 30, sine 45, sine 60 and sine 90. But now you will think, sir, you know, because you are teaching, so you might have memorized it, but actually there is nothing to memorize in it. We can create the same table for ourselves. How do we create it now? Now we are going to, I just rub it off. Okay, so I'm just rubbing it off. Now I'll show you how to make this table now. This table is very much important because this table is very much important for 9th graders, because by the time you will go in 10th grade, by the time you will be able to memorize all the values. But For ninth graders, yes, you have to remember, or sometime you can memorize sine value. If you are not able to memorize sine value, it's okay, there is nothing to worry. We can make sine values, we can create the values for sine 30, sine 45, sine 60 and sine 90. Because why I'm emphasizing more on sine standard value is because once you are able to make sine values, automatically you will be able to create cos, tan, cot, sec, cosec. So only one standard value you have to remember, that is sine. So first we are going to start how do we create the standard values for sine 0, sine 30, sine 45, sine 60 and sine 90. So now I'll write the numbers starting from 0. 0, 1, 2, 3, 4. Okay. My first step, now I'm just writing down the steps over here. Start writing numbers from 0 to 4. This is your first step. Now second step, divide the entire thing by 4. Divide by 4. So upon 4, upon 4, upon 4, upon 4 and upon 4. Second step. Third step we got, now find the square root of entire number system, entire numbers. So find square root, find the square root. So I will find the square root of each of the standard values. Let's see what do we get. Now 0 upon anything is always 0. Now root of 1 upon 4 is 1 by 2. Now root of 2 upon 4, that is what? Now 2 ones are 2 twos are, so it will be 1 upon root 2. Now nothing can happen. Root 3, because I don't have any value for root 3, so it will remain root 3. We have root 4, that is 2, so I will get root 3 upon 2, and 4 got cancelled, root of 1 is 1. So from this what did you get? Now we are getting standard values of sine theta. Sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, and sine 90 is 1. So by using these three standard values, we got sine theta values. Now once you find all the values for sine theta, now we are going to find cos theta. So how do we find cos theta? Now cos theta will be just reverse of it. So we can find cos theta by reversing the values of sine theta. By reversing the standard values of sine theta. Alright. So now sine 0 will be sine 90. So sine 90 will become sine 90 will become cos 0. Sine 60 will become cos 30, that is root 3 upon 2. Cos 45 and sine 45 will remain the same, that is 1 by root 2 as it is. Cos 60 will become sine 30, that is 1 by 2, and cos 90 will become 0, that is sine 0. Now tan theta is what? Now we have got some standard values for tan theta. Now we know that tan theta is again sine theta upon cos theta. Now tan theta is what? Sine theta upon cos theta. Now sine theta is what? Now tan 0 will become sine 0 upon cos 0, so it's 0 upon 1, which is 1. Tan 30 is what? Tan 30 is sine 30 upon cos 30, so I will have 1 upon 2, the whole upon root 3 upon 2. My 2 gets cancelled, so answer is 1 by root 3. Okay, so tan 30 is what? 1 by root 3. I'll just write it properly. That's 1 by root 3. Alright, now tan 45 will become how much? Sine 45 upon cos 45. So sine 45 is 1 by root 2, cos 45 is 1 by root 2. So 1 by root 2 upon 1 by root 2 will become 1. So tan 45 is 1. Tan 60 is how much? Root 3 upon 2, root 3 upon 2 upon 1 upon 2. My 2 will get cancelled. What is left is root 3. And finally 1 upon 0. Can you divide something by 0? No, it's not possible. So I will write either not defined or just simply write infinity sign. Anything is okay. So these are my standard values of sine theta, cos theta and tan theta. So these are what? Standard values of trigonometrical ratios. Alright? This table is very much important for all the 9th graders as well as for 10th graders. So I'm not, right now kids, you all need to understand one thing. I'm not teaching trigonometry for 9th graders or especially for 10th graders. This is overall trigo which I am doing right now. So this can be referred to any students who are from either 9th standard or they are from 10th graders. So for 10th graders it will be a kind of a revision, and for 9th graders it will be something which they are going to start with Shokatova, and then they are going to learn what is my complementary angle, and third part they will be coming across with my standard angles. And once we are done with the standard angles, so standard angles, and then we'll go to the next part which I will tell you or I will discuss is going to be the identity of trigonometrical ratios. Now what are identities? Now this identity part which I am doing right now is basically the part for 10th graders. Okay. So now 10th graders will have two basic parts. One is identity part, in which they will be proving. They have RHS and LHS proving part, and second part is heights and distance. So heights and distance I will do later. Later means during the class itself. But before we go to heights and distance, I want to show what is the identity of trigonometrical ratios. Okay, so this much, I hope this much is clear with everyone. We are doing identity. Alright, identity basically, now this part, identity, when we talk about, basically this is a kind of a rule which we came across with the help of Pythagoras theorem. Now Pythagoras theorem everybody knows. What is my Pythagoras theorem? Now I am going to prove all my identities with the help of Pythagoras theorem. Alright. So now I will take my right angle triangle again. In this we are having A, B and C. Angle B is my 90 degree. Alright. So according to my Pythagoras theorem, so in triangle ABC, okay, by using Pythagoras theorem we get. Kids, my writing is not that great, so please excuse me for bad writing. If in case there is any misspelling or something somewhere, please excuse me. Apologies in advance. Now, so by using Pythagoras theorem, what we are going to get? So AB square plus BC square is equals to hypo square. That is side 1 square plus side 2 square is equals to hypo square. Now, if you see what we have got over here, now we have got, if I assume this to be theta, we already have sine theta to be AB upon AC, cos theta to be BC upon AC. Alright, standard angles. So standard trigonometrical ratios. Now this is my first part which I wrote. Second part, dividing the whole dividing on both the sides by AC square. So what do we get? We are going to get AB square plus BC square upon AC square is equals to AC square upon AC square. This gets cancelled. We get 1. So now I will write it as AB square upon AC square plus BC square upon AC square is equals to 1. Now, can we write this to be AB upon AC the whole square plus BC upon AC the whole square is equals to 1? But what is my AB upon AC? It is sine theta. Now what is my BC upon AC? Is cos theta. So in place of AB upon AC, what will I write? I will write down sine square theta plus cos square theta is 1. This is my first standard identity which I got. Alright. So sine square theta plus cos square theta is equals to 1. Okay. So first part we got. Now second part. This was the first identity. Now we can also manipulate this identity and get two more identities from this, but that we'll do it later. Now I'll go on the second identity. That is, I'll just write down the identity in advance so that you know which one I'm proving right now. 1 plus tan square theta is sec square theta. Okay. Now 1 plus tan square theta is what? Sec square theta. Now I'll take the starting part of the proving from the first case itself, that is AB square plus BC square is equals to AC square. In the first case I was dividing by hypo, but now I don't want to divide by hypo, I want to divide by AB. What will I do? No, I will not divide by AB in fact, because I want tan. So tan is what? Tan is opposite upon adjacent. So I need AB, I need BC. So now dividing both the sides by BC square. BC square. So now what will I get? I'll get AB square plus BC square the whole upon BC square is equals to AC square upon BC square. Now I'll take them individual. So AB square upon BC square plus BC square upon BC square will become 1. That is equals to AC square upon BC square. Now can I write this as 1 plus AB upon BC the whole square and AC upon BC the whole square. Now if you see carefully, AB upon BC is what? Opposite upon adjacent, that is my tan theta. So now can I write it over here? Tan theta, tan square theta and AC upon BC. So hypo upon adjacent is what? Sec theta. So I am proving my second identity, that is 1 plus tan square theta is equals to sec square theta. Alright, this is my second identity. Now there is one more. Now third one is 1 plus cot square theta is equals to cosec square theta. Same thing. Again I'll start from the first part itself. Here AB square plus BC square is equals to AC square. That is my Pythagoras theorem. So I'll just write down the same stuff. AB square plus BC square is equals to AC square. Okay. Now after this, now again, like how we did in the first case, we divided the whole equation by AC square. In the second case I divided the whole equation by BC square. Now in this case I am going to divide the whole equation by AB square. Yes. So now dividing the whole equation by AB square, we get. Alright. Now so AB square plus BC square upon AB square is equals to AC square upon AB square. Now what will happen if I take them individually? So AB square upon AB square plus BC square upon AB square is equals to AC square upon AB square. Now this whole thing gets cancelled. I'll get 1 plus BC square upon AB square is equals to AC square upon AB square. Now again I'll go back to my right angle triangle. BC upon AB, BC upon AB, adjacent upon opposite, adjacent upon opposite, that is cot theta. and hypo upon opposite is my sec cosec theta, not sec, cosec theta. So I'll get 1 plus cot square theta is equals to cosec square theta. So these are my three basic identities of trigonometrical ratios. Alright. So today we have, till now we have seen three things. One, what was my complementary angle? We saw complementary angles. Then second, we saw standard angles. What are the standard angles? Still three of them are remaining. We'll just do it quickly. And then we saw what is my identity of trigonometrical ratios. Now after this we are just left with one part, that is heights and distance. I'm planning to do heights and distance in a separate video because it needs to be explained in a very particular way, because that is the part of the application of trigonometrical ratio. So I don't want to mix it right now, because these parts are nothing else but these parts are the introductory to trigonometry. So in the first video we have done part 1 basically, in which you will find what is my Shokato or what is my trigonometrical ratios. Now this is the second video, recorded video, in which we are doing complementary angles, standard angles and identities of trigonometrical ratios. So I just complete last three values, trigonometrical standard values, and then we'll end for that. Alright. Now so after tan theta we'll do cot theta, we'll do sec theta, and we'll do cosec theta. Now what is my cot theta over here? Now cot theta is anyways 1 upon tan theta, that's reciprocal. I will just reciprocal it. So my cot theta is 1 upon tan theta. So cot theta is 1 upon tan theta. So 1 upon 0 is infinite, not defined. And again cot 30 will be 1 upon tan 30, that is root 3 upon 1. Cot 45 will be 1 upon tan 45, that is 1. Cot 60 will be 1 upon tan 60, that is 1 upon root 3, and not defined, basically it will become 0. Alright, so this is for my cot theta. Now what will be for my sec theta? Sec theta, the kids, is 1 upon cos. So I just need to find the reciprocal of my cos theta. So cos theta, now here I can just correlate with my cos theta and sec theta over here. Sec theta is basically 1 upon cos. So 1 upon 1 is 1. Okay, 1 upon 1 is 1. Now sec 30 will be how much? 1 upon cos 30. So 1 upon cos 30 is how much? 1 upon root 3 upon 2. So I will just reciprocal it. This will become 2 upon root 3. Same thing, cos 45 was 1 upon root 2. So this will become root 2 upon 1. And cos 60 is 1 upon 2. This will become 2 upon 1. And cos 90 is basically beta 0. So this will become infinite or not defined. Now cosec has two ways of finding. One, we can just simply do reciprocal of my sin theta. Otherwise what we can do is we can just find the reverse of my sec theta. That will also, we just saw cosec theta. Now cosec theta was what? Either it is reverse of sec theta, or we can just take it as reciprocal of cos theta, reciprocal of sin theta. So cosec theta is 1 upon sin, which is, now sin 0 is 0, cosec 0 will become infinity, cosec 30 is 2, cosec 45 is root 2, and cosec 60 is 2 upon root 3, and cosec 90 is 1. So kids, here we complete today's decided part. Basically today we did three things, and the remaining heights and distance we will be doing in the next recorded video. Thank you so much guys for watching my video. Have a great day. Radhe Radhe. Jai Shri Krishna.